Hello everyone. Today we are going to discuss about how bird is swimming? Just kidding. Today topic is Manta Ray. This is not what you think.
Cause I don't give a fuck what you say. Yeah, I'ma do shit my way. So you can go kick rocks, I'ma stack bricks up, build what I want to make.
Let's get started. Underwater vehicles, also known as submersibles, are innovative machines designed to operate underwater for various purposes, ranging from scientific exploration to military missions. These vehicles have significantly advanced our understanding of the underwater world and have opened up new possibilities for research and exploration in the deep sea. I am sorry, a little interruption. If you are bored because of history, please use timestamp to move on. Check out the description for timestamps. Let's move on. The development of underwater vehicles can be traced back to the mid-20th century when the first primitive prototypes were created. Over time, technological advancements have led to the creation of sophisticated submersibles capable of reaching extreme depths and withstanding the harsh conditions of the deep ocean. One of the key advantages of underwater vehicles is their ability to access remote and inaccessible areas of the ocean that are beyond the reach of human divers. This has enabled scientists to study deep-sea ecosystems, geology, and marine life in ways that were previously impossible. Additionally, underwater vehicles have been used for a variety of commercial and military applications, such as offshore oil exploration, underwater salvage operations, and underwater warfare. There are several types of underwater vehicles, including remotely operated vehicles, ROVs, autonomous underwater vehicles, AUVs, and manned submersibles. Each type has its own unique capabilities and is designed for specific tasks. ROVs are controlled by operators on the surface and are commonly used for tasks such as deep-sea exploration and underwater construction. AUVs, on the other hand, operate autonomously and are used for tasks such as oceanographic research and environmental monitoring. Manned submersibles are designed to carry human passengers and are used for scientific research, exploration, and deep-sea diving expeditions. Overall, underwater vehicles have revolutionized our ability to explore and study the underwater world, providing valuable insights into the mysteries of the deep sea. As technology continues to advance, the capabilities of underwater vehicles will only continue to grow, opening up new opportunities for discovery and innovation in the field of underwater exploration. Unmanned underwater vehicles, commonly known as underwater drones, have become an increasingly popular tool for marine research and exploration. These sophisticated machines are equipped with various sensors and cameras that allow them to navigate the depths of the ocean with precision and accuracy. One of the key advantages of underwater drones is their ability to access remote and challenging environments that are difficult or impossible for humans to reach. These vehicles can be used for a wide range of applications, including oceanographic research, environmental monitoring, search and rescue operations, and underwater inspections. Underwater drones are typically controlled remotely by operators on the surface, using advanced technology to communicate with the vehicle and receive real-time data. Some drones are even capable of operating autonomously, following pre-programmed routes and performing tasks without human intervention. These vehicles come in a variety of shapes and sizes, ranging from small, agile drones for shallow water exploration to larger, more robust vehicles designed for deep-sea missions. They are equipped with powerful thrusters for propulsion, high-resolution cameras for imaging, and sophisticated sensors for collecting data on temperature, salinity, pressure, and other environmental variables. Overall, underwater drones represent a significant advancement in marine technology, offering researchers and scientists a valuable tool for exploring the mysteries of the ocean. With their ability to access remote and hazardous environments, gather valuable data, and support a wide range of applications, these unmanned vehicles are sure to play a key role in the future of marine research and exploration. The Manta Ray unmanned underwater drone is an innovative technological development that promises to revolutionize ocean exploration. This underwater drone, designed with a sleek and aerodynamic shape inspired by the graceful Manta Ray, aims to explore the depths of the ocean in ways never before possible. There are several key reasons driving the construction of the Manta Ray. Firstly, the ocean covers more than 70% of the Earth's surface, yet less than 5% of it has been explored. The need for more advanced technologies to explore and understand the vast underwater landscapes is paramount. The Manta Ray drone is equipped with state-of-the-art sensors and imaging technology, allowing for detailed mapping and exploration of ocean floors, marine ecosystems, and underwater geological formations. Furthermore, the Manta Ray drone is designed to collect valuable data to support scientific research and conservation efforts. With its ability to reach depths that are inaccessible to humans, the drone can study marine life, monitor environmental changes, and contribute to the protection of endangered species and habitats. By gathering data on ocean currents, water temperature, and underwater topography, the Manta Ray drone can provide valuable insights into the health of our oceans and help mitigate the effects of climate change. In addition to its scientific and environmental applications, the Manta Ray drone also has potential commercial and military uses. Its stealthy design and advanced capabilities make it an ideal tool for underwater surveillance, search and rescue missions, and reconnaissance operations. By leveraging its agility, speed, and autonomy, the drone can navigate through challenging underwater environments and gather intelligence in real time. The key features expected from the Manta Ray drone include its robust construction, high maneuverability, and long-range capabilities. The drone is designed to withstand the high pressures of deep-sea exploration and operate in a variety of ocean conditions. Its sleek design allows for efficient propulsion and maneuvering, enabling it to navigate through tight spaces and explore intricate underwater landscapes with ease. Moreover, the Manta Ray drone is equipped with advanced sensors, cameras, and communication systems to collect and transmit data in real time. Its autonomous navigation system enables it to operate independently, following pre-programmed routes or responding to environmental cues. With a long-lasting battery life and the ability to recharge wirelessly, the drone can stay submerged for extended periods, conducting thorough and continuous data collection. The design and construction of the Manta Ray, a sophisticated underwater robot, showcases the ingenuity and precision required in modern engineering. The Manta Ray is engineered to navigate underwater environments with dexterity and efficiency, making it an invaluable tool for marine research and exploration. Let's explore how the Manta Ray is built, focusing on the selection of materials, key features, and technology utilized in its construction. The Manta Ray is constructed using lightweight yet durable materials that can withstand the pressures and corrosive nature of the ocean environment. The main body of the robot is typically made from high-grade aluminum or titanium, known for their strength and resistance to corrosion. These materials are essential in ensuring the structural integrity of the robot, allowing it to withstand the rigors of underwater exploration. Point 1. In addition to the main body, the Manta Ray is equipped with a variety of sensors and equipment that contribute to its navigational capabilities. These sensors include sonar systems, cameras, and hydrophones, which enable the robot to detect and navigate through underwater obstacles. The materials used in these sensors are carefully selected for their sensitivity and reliability, ensuring that the robot can gather accurate data in challenging underwater conditions. One key feature of the materials used in the construction of the Manta Ray is their buoyancy and hydrodynamics. The design of the robot is inspired by the graceful movements of a manta ray, allowing it to move effortlessly through the water. The materials used in the construction of the robot are carefully selected to optimize its buoyancy and reduce drag, enhancing its agility and maneuverability underwater. The technology used in the construction of the Manta Ray is cutting-edge, incorporating advanced robotics and artificial intelligence systems. These systems allow the robot to autonomously navigate through underwater environments, making real-time decisions based on the data collected by its sensors. The Manta Ray is equipped with sophisticated algorithms that enable it to adapt to changing conditions, avoiding obstacles and optimizing its movements for efficiency. One of its key capabilities is its ability to reach the deepest sea levels, making it an invaluable tool for deep-sea research and exploration. With a maximum depth reach of 6,000 meters, the Manta Ray UUV can navigate the ocean depths with precision and efficiency. In addition to its impressive depth capabilities, the Manta Ray UUV boasts a maximum speed of 5 knots, allowing it to cover large distances in a relatively short amount of time. This makes it an ideal choice for missions that require quick and efficient data collection. One of the standout features of the Manta Ray UUV is its energy-saving design, which allows it to operate for up to 30 days without the need for recharging. This extended operational time gives researchers and scientists the freedom to conduct long-term studies and experiments without interruption. Overall, the Manta Ray UUV represents a significant advancement in underwater exploration technology, offering a combination of deep-sea capabilities, high speed, energy efficiency, and extended operational time. Its versatility and reliability make it an invaluable tool for a wide range of marine research and exploration applications, ensuring that it will continue to play a crucial role in expanding our understanding of the underwater world. The future of Manta Ray UUV, Unmanned Underwater Vehicle, holds immense promise with ongoing technological advancements and developments. In order to enhance the capabilities of Manta Ray UUVs, future developments will need to focus on several key areas. One crucial aspect that needs to be addressed is the improvement of autonomy and artificial intelligence capabilities of Manta Ray UUVs. By incorporating advanced AI algorithms and machine learning techniques, these UUVs can navigate more efficiently underwater, adapt to changing environmental conditions, and execute complex tasks with minimal human intervention. This will not only enhance the operational efficiency of Manta Ray UUVs but also increase their versatility and applicability in various underwater missions. Additionally, future developments should also focus on enhancing the sensor capabilities of Manta Ray UUVs. By integrating cutting-edge sensors such as sonar, cameras, and other detection systems, these UUVs can collect a vast amount of data underwater, enabling better mapping, surveillance, and reconnaissance missions. This enhanced sensor suite will not only provide invaluable data for military and scientific purposes but also contribute to a better understanding of the underwater environment. Furthermore, improvements in power management and propulsion systems will also be crucial for the future of Manta Ray UUVs. By incorporating more efficient energy storage solutions and propulsion systems, these UUVs can operate for extended periods underwater, covering greater distances and conducting more extensive missions. In conclusion, the future developments of Manta Ray UUVs hold the potential to revolutionize underwater exploration, surveillance, and research. By enhancing autonomy, sensor capabilities, power management, and propulsion systems, these UUVs can become indispensable tools for various underwater applications in the years to come.